Okay, so today we are going to continue with chapter 8.4. Last time we learned a little bit about sigma notation, and we had a worksheet which you can continue working on today if you didn't finish it last time. But as far as the workbook is concerned, we're going to continue uh, and talk specifically about sums of arithmetic and geometric series and get some formulas for those. So, um, this part at the beginning is kind of showing you how the formula for the sum of an arithmetic series is defined, how the formula is derived. I'm not going to necessarily ever ask you to derive the formula, but it comes from taking a series, let's say it has 20 terms, and then writing it in reverse order, and then adding those two together, and then getting that sum, and then dividing by 2 to get the sum of those 20 terms as a simplified expression. And then we can do the same thing with the using just the formula for a specific term of a sequence. And then in general terms, when we do it in general terms, we get this formula here, which gives us a way of calculating the sum of the first n terms of a arithmetic series. Um, I would just focus on learning how to use this first form of the equation. The second one is kind of the second formula is given to you in case you don't know what the last term is. Because if you notice here, there are three things in this formula that we need to know. There's n, a1, and a sub n. Now, n, we know, is the let me erase this box. N, as we know, is the number of terms that are being added. A sub 1 is the first term in your series, and a sub n is the nth term. Or in our case, because we're adding n terms together, this is going to be the last term of your series. Right, so all we need to know is the number of terms, the last term, and the first term. So we add the first and the last term together, multiply by the number of terms, and divide by 2, or multiply by 1/2, in order to get the sum. So if we wanted to add all of these together, we could simply take the formula approach and say the sum is going to be 1/2 times the number of terms. Now, do we know how many terms there are here? That's something that we may need to figure out. In this case, it tells us that there are 20 terms, but even if it didn't, we should have a way of finding out how many terms this is by figuring out what index term this is. So if this is the 10th term, then there would be 10 terms here. If this is the 15th term, there would be 15 terms here. But in this case, the question tells us, or the subscript on the S tells us that there are 20 terms. So we multiply by 20 times the first term, which is 6, plus the last term, which is 101. And we can compute this just by multiplying these together. So 1/2 times 20 is going to be 10 times 107, which gives us 1070. Right? So we can use the formula if we know how many terms there are, if we know the first term and the last term. Right? So sometimes some of those pieces are going to need some work to figure out. That's where the difficult part of this section comes in. So I would say you don't necessarily need to spend too much time using this formula because we can always find the last term. This formula is good if you don't know what the last term is, but we can always find the last term because we have a formula for an explicit formula for arithmetic sequences. So let's do a couple of examples here. In this, actually, I want to do part B here. In this case, I need to know three things. I need to know n. Let me write down my formula here. S sub n equals 1/2 times n times the first term plus the last term in the series. So we need to know n, we need to know a1, and we need to know an. So first of all, n is the number of terms in this series. That's not obvious immediately to me, so let's leave it blank for now. I know the first term in the series is 20. That's easy to identify. You just look at the series. The last term in the series we want to add, a sub n, is going to be -50. That also just comes from just looking at the terms of the series, so the first term and the last term. As for the number of terms, this ... we could write out all of these terms because we know that it's going -5 every time, right? Subtracting by 5. So it's an arithmetic series. So I could go 5, 0, -5, -10, and go all the way to -50, and then count how many terms there are. Or we can use the idea from last time and write the explicit formula for a sub n here. A sub n, if you remember, for an arithmetic series, is a1 plus d times n minus 1. Right, that's our formula for finding the nth term of an arithmetic series. And here we can plug in things into this to figure out what our subscript is, what n is, how many terms there are, or what number term this -50 is. So if I put a -50 here, I know the first term is 20. I know the common difference is a -5. And we don't know how many terms there are. That's what we're trying to figure out. So once we find n using this explicit formula, we will know how many terms there are. We're going to subtract 20 from both sides. That's -70 equals -5 times n minus 1. Divide by -5, we get positive 14 equals n minus 1. And then we add 1, 15 equals n. Meaning there are 15 terms. So we can take that and put it here because we know what n is. And now we can take all of these and plug them into our sum of, and now we know that there are 15 terms, so we're going to do the sum of the 15 terms equals 1/2 times 15 times the first term, which is 20, plus the last term, which is -50, and then we can evaluate this. So 1/2 times 15 times -30, which is 15 times 15 negative 225. So the ultimate goal in this section is to figure out these three pieces, n, a1, and an. Some of those pieces might require you to use the old explicit formula for finding how many terms there are, or for finding the last term in the sequence. Sometimes we have we'd be given these three terms and then just a ... Like this may not be given to you. the negative 50, and then it may just say find the sum of the first 15 terms. In that case, we would know that there are 15 terms. We would know that the first term is 20, but we would not know that the 15th term is negative 50. So again, you would need to use this formula to figure out what the 15th term is. So this formula is going to come in handy if you need to find the number of terms, or if you need to find the last term in the series. Okay, let us continue here. That's good for arithmetic. You can work through the other problems. We're going to do something very similar with geometric, except the formula is going to be different, so we're going to need different things. So I'm going to skip the part where they derive the formula and talk about the pieces that we need for the formula. This is the formula here in this box. You can also find it here. I'll write about what the pieces are here. This A1 we know is the first term. We know that R, both of these R's, I guess I'll just point to this one down here. R is the common ratio, because with a geometric sequence, we don't have a common difference, but we have a common ratio, which is what we're multiplying by each time to get from one term to the next. R is the common ratio, and then N is obviously the number of terms that we want to add together. All right, so there are only three things again to find the sum of the first n terms of a geometric series. So let's see how it works in action. This first one I think was done in the video. No, I can't remember. But I'll do this one. The sum of the first 11 terms. All we need to know is n, and we need to know a1, which is the first term, and we need to know r, which is the common ratio. So once we know those three pieces, we can just plug them into the formula and figure out what the sum is here. First of all, the question says that it's a geometric series, but in an exam situation, it may not say. It may say identify what kind of series it is and then find the sum. So you'd have to look at this and say, okay, this is a geometric because we're multiplying by negative half every time, which is my r actually. The first term I can see here is 8, right? That's my first term. And then the number of terms is given to me here. It wants me to find the sum of the first 11 terms. So we plug in the 11 here. And I think this one was actually done in the video. So I'm going to do a different example here. Let's look at part B. If you didn't watch the video, then you'll have to do part A. Or you can go back and look at the video if you want to see how part A is done. As far as part B is concerned, we need to know three things. We need to know n, we need to know the first term, and we need to know the r. Now this one's given in summation notation. So if you remember, this indexing kind of tells you how many terms there's going to be. We can also plug in this first index into the k to figure out what the first term of the series is, right? So we can kind of write this out. We don't need to write every single term because all we care about is the first term and the number of terms. But if we want to find the first term, we plug in 1 into here. That gives us 3 times 2 to the 1 minus 1 plus 3 times 2 to the 2 minus 1, and so on, all the way to 3 plus 3 times 2 to the 6 minus 1. So those would be the terms of the series. And the first term, if we simplify this here, this is 2 to the 0th power, which is 1. So times 3 is going to be 3. So that first term is going to be 3, plus the second term would be 3 times 2, which is 6, plus dot, 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 plus, and then the last term is 3 times 2 to the 5th, which is 32 times 3, which is 96. So the series looks like this if you were to write it out. The number of terms in this series, we don't need to list all of them out and count them because I know that the k is going from 1 to 6. So there are 6 terms in this series. The first term in the series, like I said, we just figure out by plugging in the first index k into here. So that gave us 3, so the first term is 3. And then the common ratio from one term to the next, if you remember this is the explicit formula for the kth term of this series. So this perfectly mirrors a1 times r to the n minus 1. Right? If you remember, that's the nth term of a geometric series. So where we find r in this formula is right here. The 2 is the r. You can also look at what's happening from one term to the next if you write out a couple of terms. But this whole thing was kind of unnecessary that I did. You could just figure out the first term by plugging in 1. You can look right here to find the r, and you can look at the indices to figure out how many terms there are. So this part was unnecessary. I just wanted to show you I just wanted to remind you how this summation notation expands into a sum. Right, and then from here we could take these 3 things and figure out what the sum of the first 6 terms is. Our formula here was given by a1, which is 3 times 1 minus r to the n, so 1 minus 2 to the 6 divided by 1 minus 2. And we can simplify this a little bit. We can say that this is 3 times 1 minus 2 to the 6th over negative 1. And then 3 divided by negative 1 is negative 3. So we can see negative 3 times 1 minus 2 to the 6th. 2 to the 6th is not extremely hard to figure out. So I think this question can be done by hand. But if you stop there, I wouldn't fault you. So you could stop there for like an exam situation. You could probably also stop here, and I wouldn't take any points off, just because I care more about do you know what kind of sequence this is? Do you know the pieces that you need for this formula? Do you know the formula to plug in? So as long as you get to this, I know that can go into a calculator and we can figure out the answer. So I'm fine with this much work on like an exam situation. Before the homework and for the worksheets that you're working on and in the workbook, you should get a final answer here. 2 to the 6 is 64, so this is negative 63 times negative 3, so it's going to be a positive 189, I think. All right. That's all that was covered for today. So are there any questions in anything that I just went over?